I said, well, that's not going to work. I got to freeze my elephant. And, you know, he said it'd probably take about 5 days. I'm sorry. He said it'd take about 5 days to freeze an elephant. I said, that's not going to work because the food in the stomach's going to rot in 5 days. You know, the acid's still working. It doesn't know he's dead. All it knows is it's acid. It's supposed to break this stuff down. I said, I need to freeze my elephant in 5 hours. They said, well, then you're going to have to find something 300 below zero, like liquid nitrogen. Well, it never gets 300 below zero on Earth. The coldest it has ever gotten. Here's a map from National Geographic. They said the coldest temperature on Earth is minus 127. That's pretty chilly. I was up in Barrow, Alaska a few months ago where it gets to 80 below zero. That's chilly. But that's still not cold enough to freeze the mammoths. What happened? I talked to a guy when I was up in Alaska. He said, oh yeah, he told me he works in the oil field drilling for oil near Barrow. He said they drill down 1,000 feet through permanently frozen ground, permafrost, and hit trees. He said one day they were drilling and hit a tree, and they always take whatever they drill out and lay it on the ground beside them to go, you know, develop a sample of what's down in the ground. He said they drilled straight through the top of a tree that was 300 feet tall, standing up. This is on the north slope of Alaska. Folks, I was just up there. There are no trees. We saw one tree growing in a Chinese restaurant inside, you know, about this big. That's it. There are no trees in Barrow, Alaska. There are certainly no trees 300 feet tall. There are very few trees in the world 300 feet tall. You know, some of the redwoods are that size, but how do you get 300-foot tree standing up under 1,000 feet of permanently frozen ground? What happened? Well, I'm going to give the Hovind theory of what I think caused the flood in the days of Noah. We're going to give this in the next session mostly. Just give you a few things to consider. Now, many people have contributed to this. I'll take the blame for it if it's wrong. It's just a theory. Some people say, I think your theory is wrong about this little point. Okay, then modify the theory. That's what it's for. It's to give you a skeleton to hang the meat on, okay? We're going to review a little science and then give you the Hovind theory. There's a law called the inverse square law, which says if two objects are attracted to each other, like the Earth and the Moon have gravity pulling them together, or two magnets, the force of attraction is inversely proportional to the square of the distance between them. In English, that means if you brought it into 1/2 the distance, it would quadruple the attraction, not double it. Inverse square laws apply when you're dealing with forces involving gravity, light, magnetism, and girls. See, when you half the distance, the attraction is quadrupled, not doubled. Many guys don't understand that. See, I travel every week. I've been home 7 Sundays in the last 14 years, which means I get to come home every week. I get 10 feet away from my wife, and it's, hello, dear, how are you doing? You know, when you get 5 feet away, it's 4 times the attraction, not 2. When you get real close, it's just too late, okay? Overpowers all resistance at that distance. So, stay 10 feet away, guys. Your problems will be solved. Anyway, next thing you need to consider, when a top is spinning, it behaves in a very peculiar way. If a spinning object is struck by something, like a gyroscope, if you bump it, it'll wobble for a while and then recover spinning, but it'll be spinning at a strange angle. Spinning tops follow actually a very predictable pattern when they're struck by something. Like gyroscopes, or with the bicycle wheels full of water that we have at Dinosaur Adventure Land. Come over their entire thing with our bicycle wheels. That you get them spinning, and it's very hard to change the spin. But they follow a predictable path. You can actually determine when it was struck by tracing back the wobbling pattern and say, oh, it must have got hit right here. Okay? The Earth obviously has had different north poles. The Earth, the Earth, they build your globes, you know, it's tilted over 23.5 degrees. Oh, it spins this way actually. But it's tilted 23.5 degrees. It wasn't always that tilt. There's quite a bit of evidence on this planet that the Earth had different tilts. Stonehenge, for instance, probably was built at a time to worship the sun or study the sun. But the Earth had a different tilt when Stonehenge was built. Same with Edixus and Amun-Ra. George Dodwell was the government astronomer for Australia for years, back from 1909 to 1950 something. He was the main astronomer for the government of Australia. He spent years studying the tilt of the Earth from historical data. He says the Earth was tilted differently down through time. He made a graph of the tilt of the Earth when the Earth is moving. He said the Earth angle of declination in relation to its orbit around the sun is changing. He said after studying all this, it looked to him like something struck the Earth 4,350 years ago and made the Earth wobble for several thousand years. And now it's pretty stable. The North Pole's still moving a little bit, but basically it's pretty stable. But did something strike the Earth 4,350 years ago? Well, that's about the time of the biblical flood, you know. What happened? Today we're tilted over, and that's what causes the seasons. The Bible talks about summer and winter. The first mention of cold weather is after the flood, Genesis chapter 8. I know there were seasons before. There was apparently no cold weather before. So keep that thought in mind. Third thing, some of the planets have craters on them. The moon obviously has craters all over the place. Mercury has craters. Many of these, Mars has craters. What happened? What caused the craters on these planets? Mars has a canyon bigger than Grand Canyon, and there's not a drop of water to be found to be proven on Mars. And there's a canyon bigger than Grand Canyon. And this article says it was carved in an almost instant Grand Canyon when a lake overflowed. Now, why can they look at a canyon on Mars and determine it was formed very quickly, and they can't look at Grand Canyon on Earth and can't determine that was formed very quickly? Here you got plenty of water on Earth, almost no water on Mars. What's their logic here? And we talk all about it in this article here. You can read for yourself about the canyon on Mars forming very quickly as a lake overflowed. I agree. I think many canyons form quickly. There's an effect in physics called the Meissner effect. A magnet will actually float on top of another magnet. If you put two north poles together, one will float on top of the other. Japanese use this for their high-speed maglev trains. The Meissner effect. All this is going to tie in what we call the Hovind theory, but you need to have a little refresher in science here. What caused all this? There are comets flying around through space, but these comets are extremely cold, like 300 to 400 below zero. Don't lick them. How many of you have a piece of your tongue stuck to a pipe or a pump handle someplace in the world right now because when you were a kid, you were as dumb as me? Okay? My brother said, I bet you can't lick that pole. I bet I can. 10 below zero in Illinois, you know. Super cold things exist in space, cold enough to freeze the mammoths. Next week, we're going to cover some more of the Hovind theory of what caused the freezing of the mammoths, the Ice Age, and the flood, and Grand Canyon, and all that. So tune in again next time. See you then. Well, welcome, folks, to the Creation Seminar Part 6. This will be a continuation of what we covered last time on the Hovind theory. What caused the flood? But before we go into my theory of what caused all this, we have to review a little bit of science. When we started last time talking about some of the things about science that you need to be refreshed about, the Meissner effect, and about super cold comets in space. Some of the comets, most of the comets out there in space are extremely cold, like 300 to 400 below zero. Now, next thing you need to keep in mind, if you throw a snowball too fast, it'll break apart. I know here we are in Florida, probably some of you have never seen a snowball before, but it's the white stuff, you know, that falls out of the sky. You know, not the pigeons, but if you throw snow too fast, it will break apart in space. You couldn't shoot a snowball out of a cannon. It would break apart. It wouldn't hold together in one piece. So if a comet was going too fast, it would break apart. We saw that when the comet got sucked into Jupiter, Comet Shoemaker several years ago. They saw the comet headed toward Jupiter. It kept going faster and faster because gravity gets stronger the closer you get, the inverse square law. And as the comet got up to a certain speed, all of a sudden, poof, it just blew apart in space. There were 27 pieces that we could see from here that hit Jupiter. Who knows how many millions there actually were. But it broke up into thousands, at least thousands, probably millions of pieces. So comets are flying through space, but they have a maximum velocity or they will simply break apart. Next thing to keep in mind, the Earth has a very strong magnetic field, but the magnetic field is getting weaker. Which means back at the time of the flood, the magnetic field probably maybe even 8 or 10 times stronger than it is today. This magnetic field protecting the Earth. And next thing to keep in mind, super cold particles sometimes are easily magnetically deflected or statically charged. For instance, we have the Northern Lights. How many have ever got to see the Northern Lights? I've only been able to see them twice, once in South Dakota and once in Canada. I had to get to an airport, 3-hour drive to get to the plane. I had to catch the plane at 7 in the morning. So at 3 in the morning, we left from the seminar to drive. So I laid in the back seat and looked out the window, and the Northern Lights were just going crazy that night. As 3 hours, got to watch them. It's unbelievable. If you've never seen them, they're phenomenal. You guys seen them in South Dakota? You live there. You don't get to see, you got to go up at night to see them. Okay, well, they're not out in the daytime. Oh, they're out in the daytime, but you can't see them. The Northern Lights are caused by the phenomena of the particles or energy being deflected to the north and south pole from the Earth's magnetic field. I think the same thing could happen with super cold ice particles. Little fragments could be deflected to the north and south pole. Next thing to keep in mind, the pre-flood world was a lot different. They had a canopy of water or ice to protect them. We covered that in Seminar Part 2. And next thing to keep in mind before we give you the Hovind theory, who on earth is Peleg? There's a guy in the Bible named Peleg. If you read through Genesis chapter 10, it's kind of a boring chapter. I hate to say that, but it's kind of boring. You know, it's all them names that nobody can pronounce but Alexander Scorby. And you come to Genesis 10:25, and it says, unto Eber were born 2 sons. The name of the one was Peleg, for in his days was the earth divided. All the rest of these guys in Genesis 10, it doesn't tell us anything about them. It says their name, and his son's name, and his son's name, and his son's name, and all of a sudden it says, in the days of Peleg, the earth was divided. And then it says his brother's name was Joktan. Well, nobody else gets their brother mentioned. Why would Peleg get his brother mentioned? Well, Joktan in Hebrew means shortening, and Peleg means divided. So who on earth is this Peleg? If you get the seminar